We navigated over to our platform, which has our third-party devices in. It's in our evaluation lab where customers can come in and evaluate SuperCloud Composer, the various branches and releases that we provide to our customer base. So we're at the landing page here, and we're going to log in as admin, which is our global admin. And we'll be challenged for a password here as well. And as I mentioned in previous videos, we have support for role-based access control and Active Directory, where you would basically log into one central credentialed platform, and we would allow you access and be able to deploy menus on the side card here dependent on your particular role. So as we always do, we take you to the landing page or the main dashboard of SCC. So any user that logs in will be taken directly to this dashboard. It's a read-only dashboard, and you can click on various different card information here to gather information about something that you're looking to perhaps capture or be able to troubleshoot an issue based on some data that you're getting back from the platform, the management platform, to make those data-driven decisions. So we've actually went ahead and registered the ProLiant DL platform, and so we're going to go to the compute element list, which is basically the hallmark of basically SCC. You perhaps in previous videos saw that we deployed this in pod view, so it's in our rack. It's been completely performed through day 0 in day 1 operation. So we're completing day 1 operation by being able to deploy an operating system and adding those applications in that need be at a later date. So the first thing we're going to do is look for this ProLiant server. So the ProLiant server is sitting in an off state right now, so we prepped it prior to this particular demo. And so I want to click here and then just sort of drill into the ProLiant DL380. It's showing in good standing. In the previous video, it was in warning status. We did some troubleshooting, determined there was some defective DIMM in there, so we went ahead and fixed that, and now it's sitting at a good health status. So any particular OS that's in a critical or warning state, we will not be able to perform any lifecycle management such as OS deployment, being able to manipulate different particular attributes within the platform itself. So we have some checks and balances in place so that we don't go ahead and deploy an operating system when it's an unhealthy server. So before I really get into sort of deploying the OS, I want to take you to a couple of other areas which sort of will give some context and grounding of what we're basically doing here. So the first section I want to take you to is the artifacts page. The artifacts page is where we basically allow you to upload various different images such as OS images or perhaps even other images that are required for you to perform, such as a fast deploy, which would be golden images, the ability to upload answer files for Kickstart files to deploy various different workloads or operating systems associated with servers. You see here we support now Rocky Linux 9.3. So in this particular deployment, if you wanted to go ahead and deploy a Rocky Linux variant on our Supermicro servers, we support that today with SCC using Cobbler servers and standard Pixie boot. But we're really focusing today on really deployment of fast deploy for third-party devices. So the first thing I want to point out to is really the golden image. So the golden image would be something that you create, has all the embedded software, maybe perhaps all your application specific in this image. This image essentially is in a raw format. So what we've done for our testing, we've actually built a raw image that contains some particular prototype or some type of simulation of creating workloads to simulate basically that our processors are occupying CPU cycles in memory and things like that. So it's a good use case for us to be able to make sure that all the various bells and whistles or metadata that we're harvesting from SCC we're able to test and make sure that those are all being provided to our administrator or our DevOps individuals. So we've uploaded this raw image, and we simply have two mechanisms that we can upload. We can upload through a standard OS image that's sitting on your desktop, and simply providing the upload function. After you fill in the appropriate metadata here, click on the upload, and it'll automatically upload into our Artifacts OS repository. We would do the same thing if we were loading an answer file. I'll quickly show you that, where you can look at answer file information associated with the environment, and then also switch firmware and system firmware as well. So here is showing you specifically a kickstart file associated with Rocky. We have different types of roles that you can create. We have preceded roles, or sort of preceded kickstart files that you can upload, that we create ourselves based on whether you're performing an iSCSI target versus an iSCSI initiator versus an NVMe initiator or NVMe target. So this is all available to you as preceded kickstarts that we provide. You're welcome to create your own or download them from the various different OS manufacturers themselves. I want to also point out in certain particular DevOps operations, you may require custom OS images that you actually build yourself, and they can be uploaded here and can perform a boot from SAN as long as they're an image. Maybe perhaps they're created through a DD command or various other ways that you maybe have a utility or a tool that you create these raw images and are able to be able to perform a boot from SAN. The golden image itself, we never basically manipulate or touch that. That stays preserved as a virgin image. And what we do is we basically take replicas or snapshots of those images, and then that's where we inject the appropriate attributes or metadata to perform the boot from SAN operation. So let's go down to the storage pool and show you what we have set up for storage pools. So in SuperCloud Composer, we have what we call as the initiator, which is the one that's performing the boot from SAN operation through our iSCSI initiator. And then we have also the target, where this particular storage resides. We have a server that we designated as a target. I'll show you in a few moments of where you can see that information itself, and you can see here that we have basically the storage pool available to us with the various different snapshots. You can add additional snapshots here if you want, or create different clones or different volumes if you like. Perhaps maybe you want to do a snapshot of Microsoft, or you want to do a snapshot of, say, Sun Solaris, or maybe you want to do a snapshot of SUSE, or any other various type of Linux flavor that you want to perform. Right now, today, we don't have anything supported right now for Rocky Linux. We're working on that. We'll provide a fast deploy service for Rocky Linux so you can perform your boot from SAN and we can inject metadata. So you'll see in the next videos, we'll inject additional metadata in there. In this particular use case, we're just going to be injecting password just to kind of give you a flavor of what we can do. We'll start building out the ability to inject VLANs and additional information such as keys and things like that in later particular videos. But for this simple video, we'll just show you a very simple use case around taking an operating system, performing a boot from SAN, and injecting in a password in that particular build itself. All right. So moving on, so we provide you with the storage pool information for both initiators and targets. The next particular piece is to show you when you actually compose a node or you deploy an operating system. So when you allocate an OS or start your deployment, we refer to that as a composed node. And that composed node is in another list, which is showing you here within SuperCloud Composer. So you'll see here specifically here, we'll delete basically this one as well because we were testing on a Dell server. But you can see the same kind of scenario. By us deleting that particular task, it'll remove itself from the composed node list. In our case, we're going to be demonstrating an HP deployment itself. So we can go ahead and look at the iSCSI here, showing you information about the iSCSI, the type of server it is. So the actual image would reside on one of our Supermicro type servers. And then any server you wanted to decide that you wanted to basically designate as the target, that would be provided. You would initiate a deployment of the OS because of our ability to do platform as a service. We have all the various different attributes and different answer files and various other special images and agents within that build. So it's just a simple click operation. You would deploy the OS as an iSCSI target. We have the answer file there. It's a one-click operation and immediately gets deployed as a target ready to perform its iSCSI target tasks and operation. All right, so moving back to the compute, we're going to again search for the ProLiant server itself. It was in the second part here. And we're going to click here, and the first thing we're going to do is come up to here and basically say allocate. So we have a warning message here to indicate perhaps you maybe not want to erase the current information. So that is a security mechanism. You certainly don't want to have leftover metadata on the build of the storage appliance. So that information is going to be basically erased to perform that boot from SAN operation. So we want to say basically yes at that point. And what it does is it steps you through basically a GUI. Now, as I mentioned previously, you can do a lot of these calls for an open API with our northbound message bus. But in our case, we're just showing you on the GUI, which is streamlined to show you how easy it is to quickly deploy an operating system and save time. So we're going to choose the fast deploy option. If you had other use cases you wanted to deploy, say VMware with a standard cobbler service Pixie boot, you can simply do that. We have an ESXi image that's in the artifacts section, which would perform a Pixie boot. You would select it, and typically the deployment of that OS would take between 18 and 20 minutes. But in our use case, because maybe perhaps you have SLAs that you need to deploy an operating system quickly, you want to be able to deploy those in seconds, then you are going to use the fast deploy service. So the next thing we want to do is basically call it HBE, and we'll call it node at this point, and we're going to say next, and then we're going to select that image from the golden image pool. So if you had a number of images out there that were snapshots and replicas, they would show up here in the list, and you would choose that particular OS image to be deployed. In our case, we're going to use the Tony Ubuntu 18 raw Ubuntu at this juncture, and we're going to say next. So the next thing we're going to do is basically provide a host name with this, so you can go ahead and hover over the I there to indicate the valid names that we would be able to give to this particular deployment itself. So in our case, we're going to just say HB node itself, and then we're going to go ahead and institute also password complexity. So if you did all these kind of characters itself, it would show that you have reoccurring digits. So we have a mechanism in place to force password complexity. So in our case, we're going to use, say, password at 123, a simple one. Maybe we'll even do a change here. I will leave it at password at 123 itself. So you can unclick the I and it'll not show the information. So the password is a required field because there's an asterisk there. The next thing we're going to do is say next, and then at that point it's going to bake and turn our deployment. So we're going to allocate and assemble, and at that point it's going to start cooking and basically start the actual deployment process. So we're going to now click on, notice we're in the compute element list. We're going to click here to the composed node list, which is going to bring us over there, and that's how we control our compute, is by logging into the IKVM or potentially watching this particular node boot itself. A little pokey here in responding to this, so just give it a second here to see if we can speed it up here. Self. Maybe perhaps we'll go here instead here. There we go. So on the composed node list section, you'll notice here that the HP system is setting in an off state. So it'll actually start its on state of performing. It'll actually power up. In here we'll show system information such as the type of server that where we deployed the OS, and it will also show you detailed information about what VLAN we're participating. We're in PVID1, VLAN 1. Yeah, likely you probably would set your Pixie network into some other VLAN other than VLAN 1. We show interface MAC address information. It's connected on G4, which is where our LAN 0 interface is for our compute to perform the Pixie boot operation. The type is it's a compute switch for CS, and you could click here for the details. So at that point, it's starting its boot operation itself. So if I were to click here, it would actually go ahead and provide the ability for us to log into the IKVM. But at this point, if I do so, it's going to lose track of us being able to connect to the IKVM. So we're going to go to the next video frame. I'll set it and queue it up for you so that we are able to see us connecting into the IKVM and initiating the boot from SAN operation itself. This is sort of a restriction of my video utility that I'm using, and so we'll see you in the next video frame where we'll queue it up and show you the device performing a boot from SAN operation. Okay.